This is Mr. Anderson for Kellogg Community College. We're going to be looking at two problems from Chapter 7, Section 1, and this covers some calculator work, some finding of confidence intervals, the use of standard deviation, and averaging on the calculator. So let's get to business here. Now this was essentially assigned after the work in Section 7.2, but I wanted to do it now because this is going to involve our calculator. So what we have on, we'll get the page numbers and the problem numbers all set for you here. This is going to be on page 366. We'll first do problem number 10, which I'm glad you're watching since the answer is not in the back of the book. And then after this, we'll do problem number 12. Now, what they looked at here is they looked at 32 randomly selected colleges that had less than 12,000 students and looked at the faculty size, and they gave 32 pieces of data, and they asked you to find the confidence interval where our confidence interval will be 92%. What is the average number of employees then with a 92% confidence interval of these 32 of all colleges based on this random sample of 32? So the first thing we need to do is we need to figure out what this means for us here. And normally we've dealt with 95, 99, and 90%, but this is the first time dealing with something that wasn't on there for one of these confidence interval problems. Well, my alpha is going to be 8%, which means my alpha divided by 2, since this is a two-tailed test, is going to be 4%. Now, if I change all these over to decimals here, this is 0.92, 0.08, and 0.04. Now, I need to find the z, because this is over 30 pieces of data, z alpha divided by 2 score. So I need to look up this on the chart. Now, there are two places to find it. There is 0.0400, and also on the other side of the standard deviation curve, since the standard deviation curve is symmetric, it's going to be at 0.9600. So adding 2 zeros to each of these might be a little helpful when we have to go hunting for things on the z-chart. So keep in mind that we're going to be looking at 0.9600 on our z-chart. And if we looked at 0.0400, it would give us the same z-score, but negative. So let's go erase this right now and bring up our chart. So here's our chart. If I look up 9600, let's see, 9600 isn't one of these perfect numbers on the chart. It is actually pretty close to here. This would be 0.9600. So this is my value I'm going to go with. So 1.70, 1, 2, 3, 4, 5. So my z of my alpha divided by 2 is going to be this 1.75. And if I go to the other part, which is 0.0400, it'd be negative 1.75. So plus or minus 1.75 for my confidence interval, it is. So let me go erase that, go back to my blank page again, and write down the information. But what we really need here is we really need to get our information typed into the calculator too. Notice it didn't give us the average, but it did give us the standard deviation. Now I will show you where we can type this in by clicking on the stat key and then clicking enter, and you'll notice that my list 1 is where I have all the data from that problem. Once you type everything in there, here's the shortcut to find your average and standard deviation. Stat, right, 1, enter. Now the average is going to be 346.3, and we're going to round it to 1 decimal since the data points were all whole numbers. And the standard deviation they want us to use is this one on top, which we actually used for any data points under 30. And that right there, we're going to allow it because the book forced us to. But again, this standard deviation down here would be better used for data points over 30. But since the book said use 165.1, we will go ahead and use that. So let's go back to drawing here and get through the problem. The things that we knew already from the beginning is that our n, our standard our sample size is 32. Our average of the 32 colleges was 346.3. We're rounding to one decimal there. Our standard deviation told to use this one in problem number 10 was 165.1, which is right there. But again, this I would use for under 30 pieces of data pretty reliably. And then I would, let's keep moving on here. We've got our confidence interval, or our z of alpha divided by 2 was plus or minus 1.75. So our confidence interval formula is going to be our x bar plus or minus our z alpha divided by 2 multiplied by our standard error of the estimate, which is going to be the standard deviation divided by the square root of the sample size. So what we have here is 346.3 plus or minus 1.75, and then that is multiplied by, and the s is going to be 165.1, and then our standard deviation is the square root of 32. Now I'm going to use the calculator here, and if I do this, you would actually see the stuff go away. What this then will give us, and I'll show you, the answer first, and then kind of go through, how we got to that answer. The answer in the book would be around 295 to 397. It gives a kind of some flexible motion there between 295 and 397 because we have rounding errors. So let's actually show this on the calculator. The words are going to go away. So if I was to type this in, I kind of like to, if this is one of the ways you could do it. If you are careful with your parentheses, you can do this all in one shot. So we're going to go 346.3 minus, we'll do the number on the left first, 1.75 times the quantity of 165.1 divided by the square root of 32. And close that off twice, and this gives us our low end, which was around 295, and we go to 0.2. Now if we click the second key and the enter key, notice the entire equation comes back, and we can use our cursor keys and change that to a plus to find our other number, which is 397.4. I strongly recommend this way of doing it on the calculator if you're very accurate in data entry, and also can understand your parentheses and order of operations. For the second problem here, we have a situation where we have 36 first semester GPAs from a random selection of freshmen at a large university. So I took the time and I put those 36 GPAs that were randomly given to me into list 2. Now what I'm going to use here is the average and the standard deviation, even though the book has kind of like told us which standard deviation to use. So let me go to my stat right 2, not 2, sorry, stat right 1. But before I hit enter, since the data is in list 2, I'm going to click second 2, and this takes my statistics from list 2 instead of list 1. So now I have my average GPA, which I'm going to basically round to 2 decimals at 2.82, and the book forces me to say I want my standard deviation to be 0.62, even though with more than 30 pieces of data, I would use 0.61, the one below it here. But again, since we're forcing to use the book's work, we'll pretty much keep it that way. All right, so let me switch over to my pen, which freezes my calculator, and we're going to continue with page, I wrote off the screen there, page 366, number 12. All right, so now what we have is I've got 36 students. I've got my average of 2.82, and because the book tells me so, it's wanting me to use the standard deviation of 0.62. However, with over 30 pieces of data, I would use the one below it. Not a big difference, of course, but as our sample size gets bigger, this is the one we want to use here for over 30 pieces of data, the sigma x instead of the s of x. All right, so now what we need is the confidence interval. The confidence interval in this problem is 99%. And that means our alpha of the problem is going to be 1%. That means my alpha divided by 2 is 0.5%. So when I look this up on the chart, again, if you want to add some decimals here, this is 0.99, this is 0.01, this is 0.05. If I add 2 zeros to each of these to help me out, I'm going to look up at 0.0500 on the Z chart and find my Z number. And I'm also going to look at 0.9950 and look at these two Z numbers. And these two Z numbers are very common, and I'm not going to bust out the Z chart for this one since I have done this many times. The number we're going to use is plus or minus 2.58. So if you look at 2.58 on the charts here, we are going to choose the higher of the two values instead of 2.57 because that's going to give us a little bit worse of a confidence interval, and in statistics we always want to side on the worst side. So our formula is going to be x bar plus or minus, this is z alpha divided by 2 times the standard error of the estimate, so it's going to be the standard deviation divided by square root of n, which is 36. So again, plugging my numbers in here, this is going to be 2.82 plus or minus, this is my 2.58 times 0.62 divided by the square root of 36. All right, now the answers in the book are going to be anywhere between 2.5 and 3.1. So I'll show you this on the calculator and show you how you get those answers from about 2.5 to 3.1. And the writing will go away, and here's the calculator work. Boop. Okay, so starting with those numbers again, we have our GPA average of those 36 students at 2.82, and we'll do the minus first, 2.58, which is our z-score from the confidence interval of 99%. Then we multiply that by our standard deviation, 0.62, divided by the square root of 36. And then close that off twice, and then that gives us one of our two answers, which is around the 2.5 that the book estimated, so 2.55. And then we'll hit second and the enter key, and then we can go back and change that to a plus, and this gives us the number on the high end, which is about 3.1 or 3.08, or an 09 if you round correctly. So our answer for the problem then, using these two numbers, is that based on the random sample of this university, we can say that we are 99% confident that the rest of the averages of universities of this kind of size and this kind of demographics is going to be between 2.5 and mu here, since we're looking at the entire population, and 3.1. Rounding wise, if we went to 2 decimals, which we should, this would be 2.55 and 3.09. All right, well, thank you for watching, and keep in mind that you will be using this technique on 4 of your last problems on the test, so make sure that you get used to typing things into your calculator, looking up the correct averages and the and the standard deviations appropriate to the sample size of that class. Thank you very much, and appreciate watching.